last presentation in one of their out of 6 sessions. So is parallel sessions is always complicated, but I'm going to try to give one rough explanation about the concept of social machines that I'm working. So you may have seen me during these days here in this stage. My name is Galar. I'm professor of condition monitoring at Luleå University of Technology, and I'm also the head of maintenance and reliability in Tecnalia, the Spanish Research Institute. The main goal of this is to move from the traditional version of assets we have now in the industry and everywhere, number of assets that are typical physical assets, industry and transportation, and also intangible assets. All these assets are producing a bunch of data, a tremendous amount of data, and this has created, as we can see during these days, a data-driven industry. And for that, we have created a number of models to make, basically, in my domain, that is maintenance, predictive maintenance, predictions, diagnosis, maintenance decisions, etc., to maximize the performance of our assets. But in this journey, we have failed scaling up this solution. We have failed scaling up this solution because still we expected, but by 2020 we had most of the AI deployed in the industry, and has not been like this. Why is like this? What is the problem that we have when we want to deploy all this AI in the assets? Why we have not been able to do that? Okay, let's talk about two main problems. First, the infrastructure. And the infrastructure is very fundamental when we talk about mistakes to deploy this AI in the assets. When we talk about assets, we can put some intelligence on the asset. Think of a train, a car, a machine in a factory, wherever, a compressor, a centrifugal pump. You can put some technology on the asset, some edge, some cloud, everything sent out to the cloud, or some mix, some fog computing. Definitely, the traditional approach of sending everything to the cloud is no longer valid. It's no longer valid because if we have to send massive amount of data to the cloud, definitely we are going to collapse in many environments where you don't have the energy, you don't have the bandwidth, or you have to wire many things. In this case, we have to think about a mixed solution. For maintenance, we have sometimes the trend to do fully centralized. Okay, take all the sensors and send everything to the cloud and do the analytics there. This is good. Actually not. Not because if you have thousands and thousands of sensors and you have to deploy everything there, definitely is not a solution. You have the semi-centralized that seems to be quite okay. You have some sensors with some intelligence, and you send to the cloud some information when this information is needed to be processed. This is quite okay because you don't overload the transmission, etc. And you have the fully decentralized decision support system, when every machine has the intelligence and they can take their own decisions based on their own data collection. Seems that the totally decentralized solution is the best to scale up solutions, because you can keep on connecting machines and you don't have to shut down the system or whatever. And indeed, this decentralized solution, if you look how edge computing versus cloud computing is evolving, we can say that in the industry, definitely we have to go for edge computing. Indeed, when you go to distributed assets, like for example, electrical substations that during the pandemic have been extremely critical because electricity, water supply, etc., they have to be there even though the humans are not there to take care of the facilities. That's why these kind of solutions are really important. And in this case, if you look up, you can see that the edge computing, when you have different substations, different transformation centers that are remote, unattended, and with difficult access, maybe edge computing is the solution. And edge computing is also good because when you have a fleet of, for example, trains, and you have to transmit everything to the cloud in the traditional approach, and the cloud is the center of the universe where all the analytics is performed, is not that good, because you have to do a number of things in order to transmit and revert the value of the analytics. However, if you share the models, if you have just the models the model share, not the data. If you had edge computing in each of these places, and what you share is the model, and once you share the model, the best performer is the one that is populated to the fleet, then you are dramatically reducing the amount of data and you are optimizing the whole system because you are just populating the best performer model. Then definitely the AI in the edge seems to be quite good in order to have this kind of fleets and scale-up problem in terms of hardware. And definitely, when we go for these solutions, we have to be aware that if we have, let's say, number of cars running in the streets, and one of them is performing good because has evolved the model very well, don't share the data of that car, share the model, populate the model, and then the learning curve of the fleet is much, much better. In this case, we start talking about the concept of the social assets. Okay, we have a fleet, and the assets can talk among them to some extent. They can share some information, and they can leverage knowledge based on their own experience. And this is the beginning of my work in terms of social assets. But we have one additional problem, the analytics. Which kind of analytics we expect when we talk about social assets? Of course, we talk basically about all types of analytics. The descriptive analytics is the basic one. This is healthy, this is unhealthy, or at least different, warning type. What is the problem of the descriptive analytics? Here we are talking about many analytics, but when we talk about industry and transportation, the problem of the context is a huge problem. The same asset running in different contexts behave different. That's why the social assets needs to be aware of the context, and that's why context awareness, in order to distinguish same assets with different behavior, is essential. For example, if you take a train that is running in Sweden or is running in Spain, the same train in different weather conditions, in different location conditions, is behaving totally different. That's why the social assets, they must be aware of the context. But also, when we go for diagnostic analytics, we have a problem as well. In social assets, many of the assets, they are going to find a diagnostic, that is the detection, identification, and localization of the failure. Are we aware of all the failures that may happen? Maybe not. And then in the analytics, we have another problem for the social assets, the problem of the black swans. Problem of the black swans that are these events, very rare, events that are extremely rare, but when they happen, the catastrophe is for sure, and also if you look back in the mirror, you can find an explanation for that. This is really the big problem we have in the industry when we talk about diagnostics. It's because the social assets may not see what is going on, and they may find a black swan that they are not able to identify. And we have these black swan losses. That is when the entire population of social assets is not able to distinguish what is going on. When we have this kind of event, unfortunate event, that no one in the population is able to see what is going on, we have a black swan. But if we move further in the analytics, we go for predictive analytics. That is, okay, what is going to happen? And here we have even more problems, because the social assets, when they are connected, they want to know what is going to happen with them. And for that, what we call prognosis is the prediction of the remaining useful life. We have some what we call prognosis obstruction. Not everything is predictable. You cannot predict the next couple of minutes, and you cannot predict the next 20 years in the life of one asset. This prognosis obstruction is what we call, I really like to call the challenge, the picture of Dorian Gray in terms of challenge for predictive analytics. And what I'm saying, the Dorian Gray picture in terms of challenge, because you cannot predict certain things because you don't have records, you don't have information to do such prediction. And that's why, in this case, is one of the challenges in the prediction when we talk about social assets is that you have to combine the information from the assets together with the information, in this case, from the engineers, etc. And you can go for more sophisticated models that I'm not going to explain here, but basically hybrid models where engineering comes together with data science to co-create a solution. But we have to move forward in this kind of social assets. Prescription, these assets should be able to take the proper decisions, and for that, they should be able to prescribe what to do in different scenarios. Means that a machine running in different conditions is going to degrade and operate in a different way. Are we able to provide the machine these capabilities to see what should be done every time in function of the different scenarios? This is what we call prescriptive analytics. And prescriptive analytics is when I'm running my machine in different conditions, the degradation is different. Harder conditions, faster degradation. Softer conditions, slower degradation. And then I have some kind of prescription that, for example, in railway is quite mature now, that the different remaining useful life depends on the operation. And this is normal. When we have to do a prediction, it's not just in function of your, let's say, ID. The prediction of your remaining useful life is based on your life, on your habits, and this is what happens with the assets as well. An asset is not born with the expected remaining useful life. Depends on the operation. And the prescription has another challenge when we want to do prescription for the asset. And this is what we call the digital butterfly effect. What does it mean? I want to prescribe different decisions for my assets, and I have to define different scenarios for my assets. But are you sure that when you put everything in your AI, you are putting all the data that you need? Are you sure that you are not missing information that is relevant? And the most important question, are you sure that the AI is going to find the invisible things that you cannot see? Because when I put all the data in my system, what I expect is that the AI is going to help me finding things that I cannot see at a glance. And this is extremely relevant. But for that, when I talk about the digital butterfly effect as a challenge, the key question is my machine learning model enough? My consideration of the whole world is enough? I'm considering the proper context for that. And this is what we call the digital butterfly effect. Then, okay, with these challenges, we have to do some social assets. Why? Because all these analytics that I have mentioned is with one guy in front of the computer that is going to decide if the remaining useful life is okay, if the operation 1 is okay or operation 2 is okay, and finally the prescriptive analytics still has one person in front of the computer to take the final decision. And I want to move forward. I want to move to the cognitive analytics, where the machines can decide by themselves. And for that, the solution is the concept of social assets. Social assets, that is the same concept that we talk the social network for the people. In this case, we are talking about Twitter, Facebook, whatever, that connect people and let the people be aware and more informed. In this case, actually is the same architecture. But we have one problem here. If you want to connect different types of assets, if you are talking about one assembly line where you have a robot, you have a conveyor belt, or if you want to connect different cars, this Volkswagen brand, Tesla, whatever, and you want them to talk among them, definitely the proprietary systems, the communications among them, is a limitation. It's a limitation because the big players, they have designed their own protocols and they don't want this kind of open one-to-one communication. Then I have to do some middleware. And what is the middleware? The digital twin. In few words, if the assets cannot talk among them, the digital twins of these assets, they can. And this is what I do. Basically, I virtualize every asset to virtualize like the language in order to have the same language for all of them. And then in the digital twin level is where I create this Facebook where the machines can share, for example, events, pictures, text, information, or models without human intervention. Without human intervention means that we are providing some kind of self-awareness for the machine. What are the different layers and architecture for that? The first one is the virtualization. Virtualization is something that we have to do. Every asset is creating a number of data, input data, output data, models, etc. We have to put everything in the same language in order to have the digital twins properly connected, and these digital twins will be able to send data among them. Then the virtualization, the virtual asset, what does is basically this common language, this kind of Esperanto, in order to connect all the machines. Once we have these machines with the virtualization, we go to the digital twins. And the digital twins, we don't need exact replicas of the digital twins. We don't need that all the digital twins look like the same. No. The only thing we need is the module of virtual asset to talk among them. But the digital twins, they are going to have analytics engine, they are going to have some inputs and some outputs, and some of the twins will have some data repository or not. But in this case, is where the twins, in this kind of meta space, they can talk among them. And once we have the digital twins that so far we have not used the digital twins anywhere, we can go for the last one, that is the social platform. And you may wonder, why you need the social platform for the assets. I was talking about self-awareness, and this is crucial because if we want to remove the human from the picture, the asset has to be self-aware. Self-aware means that in this architecture, the asset needs to be aware of the context, aware of the machines that are there, the peers that can be close to it, and aware of two things: its health and its performance. If you are running 10 kilometers per hour and you have your gym staff to measure the heart rate, you can keep the running speed constant, but you will see that the heart rate is increasing because, of course, keeping your performance, you are deteriorating your health. The machines need to connect both dimensions as well, performance and health. Once they see that they are self-aware with a health limitation, they will have self-awareness. And with this self-awareness, they will be able to get the second capability that we are going to provide, the self-preservation. Self-preservation because in a social network, the basic service that we can start with, and I think that is considered, I would say that is some kind of success, is the self-preservation where the machines share maintenance needs or share some kind of concerns about the health. For example, if I'm in my assembly line where a robot and a conveyor belt, they are working together, and the robot is deteriorating the health, maybe it needs to say to the conveyor belt, okay, you have to slow down your speed because I'm highly deteriorated now, and then I have to change my operational profile. Then this connection between twins should be without any kind of human intervention. In terms of railways, for example, we are doing that in terms of sharing models that the best performer, mixing metros, trams, and high speed, but all of them, for some subsystems like HVAC, engines, etc., they share the models. If the model is updated with some event that was not there, then, okay, guys, I'm sharing my model because I have news that this model is more updated than yours. And the rest of the model is populated among them. Then, basically the collaboration in the layer of the digital twins, the first level of collaboration that I'm working is with the self-preservation for this kind of services. And in this service is where we can have the different prescriptions made in automatic way, and made in automatic way where the self-preservation and healthcare is maybe the first of the services. And in this case, we will go to the maximum level of analytics, that is the cognitive analytics, that is where we have maybe the highest autonomy of the machines. In few words, what is important for me to transmit today in this small slot of 20 minutes is that in machine to machine is very precious if we can connect the assets when we have large fleet. The machines, maybe they cannot talk among them, but the digital twins, definitely they can, and it's the entity that we have to consider. And believe me that after the pandemic, the coronavirus, this kind of social network of assets where the human has been proven as one of the most unreliable parts of the chain is really nice to have the aspects of digital twins talking among them to take these decisions in an attended way for remote locations without human in the loop, and then doing our assets more resilient and more robust. Thank you very much.